Today we'll be solving the latest 2018 October-November paper, the variant 1 of paper 4. So question number 1, we have been given a mass of a train which moves from rest, and a distance time graph is drawn. The first part requires requires us to find the average speed during the first 120 seconds. So for the 120 seconds we have to find average speed, so we'll go by the formula. Average speed is total distance by total time taken. So its total distance covered by the train is 4800 meters, and the total time it took it to cover the distance is 120 meters. So the answer is 4800 divided by 120 is 40 meter per second. So the next question requires us to find the speed of the train at time t equals to 100 seconds. So 100 seconds is like over here, and if you can see, it's a line with a constant gradient. So for the distance time graph, if we find the gradient of this constant line, or the line which is increasing, uniformly increasing, we'll find the speed of the train at 100 seconds. So we'll take 2 points. I've already marked these 2 points. This point is 1110, and it's 4200 on the y-axis, and it's 90 here, and 3000 on the y-axis. So we'll use the formula of gradient, which is y2 minus y1 divided by x2 minus x1. So the values we have are 4200 minus 3000, and that gives us 110 minus 90. So for quick calculation, 4200, it's 1200 divided by 20. So it would give us around 1200 divided by 20. It gives us 60 meter per second. Moving on to the next part, we have been asked, describe how the acceleration of the train at time t equals to 10 differs from the acceleration at time t equals to 20 seconds. So if you look closely at time equals to 100 seconds, the distance is increasing uniformly with time. That means the speed is constant, and if the speed is constant, there is no acceleration. And at time t equals to 20, the rate of increase of distance is increasing. That means the speed is increasing per unit time. That means at 20 there is acceleration present. So we'll simply write at t equals to 100 seconds, the acceleration is 0, and at t equals to 20 seconds, the acceleration is positive, or we can write the acceleration is greater than 100 seconds, and or we can just simply write there is that acceleration exists. And for the next question, the initial acceleration is this. Remember, the mass of the train was given 5.6 into 10 raised to power 5 kilograms. So we have to find the resultant force. The formula is, which is resultant force is equal to mass into acceleration. We have to find the resultant force. So putting in the values quite easily, it's 5.6 into 10 raised to power 5 into 0.75, and that would give us the answer 5.6 exponent 5 and multiplied by 0.75. It's 4.2. We'll write it in the standard form. It's 4.2 into 10 raised to power 5 newtons. Remember, Newton is the unit for force. At time equals to 120 seconds, the train begins to decelerate. What is meant by deceleration? Quite easily, deceleration means a decrease in speed or velocity per unit time.